Hey guys, Mr. Fraser here from NeonMaths, Bright Maths, Bright Future. In this session we're going to look at how we solve simultaneous equations, but not drawing them by using algebra. So we're going to look at the algebraic method for solving simultaneous equations. Simultaneous. Now, there are two different ways of doing this. In this session I'm going to be focusing on solving simultaneous equations using elimination. Stay tuned to find out how.
When they come up with the root sign down, lethal weapon in your mind, like a gun without a sound. No shortcut, no mark scheme, quit your chattering. It's your discipline, lets you stay true to your regimen.
So in one of my other videos, I show you how to solve simultaneous equations by drawing graphs. If you haven't done so, it might be a good idea to check that out. Now in its simplest form, simultaneous equations, we're given two equations or more, but in these cases we're going to be solving a pair of simultaneous equations. So we're going to get given two equations and we're going to be asked to find a solution that satisfies both of them. Now, you can do this by trial and error. It is possible, but it's crazy. You don't have enough time in a maths test to do it, and there are way better ways to do it. And we all love algebra, so let's do some algebra. Right, so let's have a look at this example over here. Now, in this question, we have two equations, 3a plus b equals 1 and a plus b equals 7. And I want to know the value of a and b that satisfy both of these equations. Now, at the moment, we've got a's and we've got b's and we've got constants. We've got so many variables. So the first thing that we need to try and do when trying to solve simultaneous equations is to remove one of those variables. Now, at the moment, my b's, I've got one b here and I've got one b here. So it would be quite easy to get rid of them by subtracting the entire equation from the first equation. So I'm going to put a little minus in here. So I'm going to do 3a, take away a is 2a, b minus plus b, that's b take away b is 0. If you don't get a 0, you've done it wrong, so start again. And 1 take away 7 is negative 6. All I need to do now is solve for a. And that's the first part done. So now all we need to do is substitute it back into one of the equations to find out what b is. I'm going to substitute it back into the second equation because it's easier. And I'm going to solve for b. b equals 10. How did I know to take these two away from each other? I'm going to write something up here now that's going to help us with the next question. Right, das. That's all I use to remember. Different, add, same, subtract. Okay, so that's just a little thing that I use to help me remember what I'm doing. I'm talking about the b's. Because the signs are the same on the b's, because they're the same, I subtract. Let's have a look at a different one. We want to solve these two equations simultaneously. Now, at the moment, I can see that my y's, I've got 2y in both of the equations. Well, actually I have positive 2y in the first equation and a negative 2y in the second equation. What would happen if I tried to do the same thing as last time? If I tried to subtract the second equation away from the first one, what would happen? Well, 3x take away 5x would give me negative 2x. That's fine. 2y take away negative 2y. Well, a negative and a negative when they're next to each other is a positive. So 2y plus 2y is 4y. And then 11 take away 13 is negative 2. So I've still got x's, I've still got y's, and I've still got numbers. That hasn't helped me. What I need to do this time is I need to add them together. The signs are different, so I add. Different, add, same, subtract. Das. So we've got to add these together. So 3x plus 5x is 8x. 2y, and to that I'm going to add negative 2y. Well, that's 2y, take away 2y is 0. Add these together and I get 24. Okay, notice I've got rid of my y's. That's the whole point. That's the thing that I need to start off by doing. I need to get rid of one of my variables because there are too many, it's too confusing. So then solve for x. Can you remember what to do next? All we need to do is substitute this value into one of our original equations. Pretty straightforward, isn't it? Yeah, when they're like this, they are. These are fun. These get a lot harder. When you go on to study maths at an even higher level, you're going to look at simultaneous equations where we've got three different equations with 3 different variables. But let's move on and let's have a look at a slightly harder version of a similar question. What makes this question a bit harder than the last one? Well, you'll notice that unlike the last 2 questions, neither the coefficients of my x's nor the coefficients of my y's are the same. So we can't just go straight to adding or subtracting these equations to remove one of those variables. So we need to manipulate it. Now, I either need to have my x's or my y's the same, because ultimately my goal is to remove one of those variables. The easiest way of making them the same is multiplying the entire first equation by 2, because then I'll get 4x plus 6y equals 14, and my 6y's then equates to each other, so I can either, if they're different, if the signs are different, add them, or the signs are the same, subtract them. So I'm going to label this equation 1 and this equation 2. Right, now what I'm going to do is I'm going to multiply all of equation 1 by 2. So I'm going to do 2 multiplied by all of equation 1, which gives me 4x plus 6y equals 14. I'm going to leave equation 2 just as it is. At this point, I need to think, well, am I going to add these together or am I going to subtract them from each other? Well, they're both positives. Different add, same subtract. So I want to subtract these 2 equations from each other. Right, so 4x take away 3x is just x. 6y subtract 6y is 0. If you don't get 0, you've made a mistake. And 14 take away 15 is negative 1. So my first solution is x equals negative 1. What do we do next? We substitute that back into one of the original equations. Which one? Well, let's do the first one, because then I only have to multiply it by 2. So I'm left with 2 multiplied by negative 1 plus 3y equals 7. This becomes negative 2 plus 3y equals 7. So that means 3y, add 2 to this side, add 2 to this side equals 9. That means y equals, well, I'm doing the inverse of multiplying by y, multiplying by 3, so I divide by 3. 9 divided by 3 is 3. So there's my second solution. Now, there are an infinite number of solutions to this equation. There are a lot of different values for x and y I can substitute in here to make this true. There are an infinite number of solutions to this equation over here. I can substitute lots of different numbers for x and y to make it equal 15. But there is only one solution that satisfies both of these equations. And that solution is where x is minus 1 and y is 3. I could substitute these values back into these equations to check that I've got them correct. We're going to have a look at another example, and I'm going to show you something that I often do to avoid having to deal with different add, same, subtract. I always make them different. Right, so here we have a slightly more complicated example. Why is it more complicated? Well, in this case, I'm going to need to manipulate both of the equations. I could either make both of the coefficients of d the same or the coefficients of a the same. I'm going to do a because it's a slightly easier task. But I'm also going to do something slightly different here, which will save you from ever worrying about this different add, same, subtract. I prefer the different add bit. So what I'm going to do is when I manipulate these, I'm going to manipulate them so that the coefficients of a's have different signs in front of them. So let's start by, well, the lowest common multiple of 2 and 3 is 6. So I'm going to multiply the first equation by 3. So that gives me 6a plus 9d equals 54. Now, I would normally multiply all of this by 2 so that it's also 6a, but because I want the signs to be different, I'm actually going to multiply it by minus 2. Okay, so I hope you can see why I did that. Now, because the coefficients of a are 6a and negative 6a, I can just add the two equations together. 6a added to negative 6a, well that's 6a, take away 6a, which is 0. If they don't cancel out, you've made a mistake. 9d plus 8d is 17d. And 54 plus 14 is 68. Now if I divide both of these by 17, I get D equals 4. Well, what do I do with that? I need to substitute it back into one of these equations. I'm going to substitute it back into the first one because it looks the easiest. And that's it. So, nice handy little trick. If you don't want to do that, remember DAS, different, add, same, subtract. If you do remember it, then you're always only going to ever have to add your two equations together. That's it for solving simultaneous equations by using the elimination method. It's called the elimination method because we eliminate one of the variables. We can also do this by doing substitution. And we tend to do that when we're solving simultaneous equations where one is a linear and one is a quadratic. So, if you want to find out more, if you want to learn how to solve simultaneous equations by using the substitution method, check out my video on solving simultaneous equations where one is linear and one is quadratic. I hope you find this useful. Please subscribe to my channel.